Okay, so in chapter 4, we're going to talk all about bonding. And there's two types of bonds that we are going to talk about in this chapter. And that is something called an ionic bond and a covalent bond. Okay. So we're going to start with ionic bonds. We'll talk all about them, and then we'll spend the next few videos in ionic bonds, and then we'll move on to covalent bonds a little bit later. So ionic bonds form between ions. They're called compounds. Compounds formed between ions. So remember back in chapter 3, we defined what an ion was. Remember, an ion is an atom that has gained or lost electrons to have a full outer shell, to have a full octet or duet in the case of hydrogen, like its nearest noble gas. So compounds form between ions. So what's important about an ionic bond is an ionic bond always forms between a metal and a non-metal. So this is important because back in chapter 1, when we talked about the periodic table, we saw that on the left-hand side of the periodic table were the metals, and then on the right-hand side of the periodic table were the non-metals. And there was that metalloid staircase, that separated the metals from the non-metals. So you can determine what type of bond a compound is based on the location, because an ionic bond is between a metal and a non-metal. A covalent bond is between two non-metals. We'll get to that later. But when you're looking at a compound, it's important that you're able to first identify what type of bond it is, because the way that we name it, the way that we write it, everything has two different sets of rules for ionic versus covalent. So ionic is between a metal and a non-metal. So let's just look at an example of sodium chloride, NaCl. So sodium, Na, is sodium. It's actually the sodium ion. Sodium is a metal because it's on the left-hand side of the periodic table. Chlorine, this would actually be the chloride ion, is a nonmetal. So this is an ionic bond between a metal and a nonmetal. So this is kind of the basics for ionic bonds. So let's talk about covalent bonds for a minute, and then we'll come back to ionic bonds. So a covalent bond is sometimes called a molecule, compound, or molecule. A molecule is actually technically a covalent compound. You cannot have ionic bonds that form molecules. You can have covalent bonds that form molecules. Compound or molecule is acceptable when we're talking about covalent bonds. Most of the time in biology and biochemistry, we refer to compounds as molecules because they are held together by covalent bonds. So you'll kind of hear them used interchangeably in your textbook, and with me, just understand that if it's talking about a molecule, it's always a covalent bond. So covalent bonds are always made between two or more nonmetals. So remember anything on the right-hand side of the periodic table. So let's look at an example. CO, this is carbon and oxygen. So this is carbon, which is a nonmetal. And this is oxygen, which is a nonmetal. So this is between a metal and a nonmetal. We would call this carbon monoxide, and we'll learn about the naming of this later. So remember, like I was saying about the periodic table, and remember there's this metalloid staircase here. And then remember, everything to the left of the metalloid staircase, these are all metals. And then everything to the right of the metalloid staircase, these are nonmetals. And then remember, things along the metalloid staircase are called metalloids, and they kind of have properties that are kind of like metals, kind of like nonmetals. I won't ask you anything about metalloids with these because there's a lot of exceptions to the rule. The one exception to the periodic table is that hydrogen over here is really a nonmetal. And it's just an exception to this rule. It doesn't really belong anywhere on the periodic table. It gets put here, so it's an exception to wherever you would put it. So this is how you could identify the type of bond between any two elements. If it's a metal and a nonmetal, it's ionic. If it is two nonmetals from over here, then it is covalent. So you would just look at where it is on the periodic table. So sodium is somewhere over here. Chlorine is somewhere over here. I know that's ionic. Carbon is over here. Oxygen is over here. I know that's covalent. There's two totally different sets of rules for ionic bonding and naming versus covalent bonding and naming, which is why the first most important thing that you need to do is identify if it's ionic or covalent. And then again, the exception is hydrogen is a nonmetal, even though it is found to the left of the metalloid staircase. Okay.